All right, well, things are progressing. I've got these trimmed out. So I'm trimming these down. I got one more of these to go right in there. Is the cone. So if people don't understand what's going on here, this cone translates in and out.
Cool.
Okay, this came out really good. I think I'm going to have to remake this part. I was thinking that I could get away without having that. There's a center shaft there, but I think that I can't get away with not having it.
It'd be too much friction for it to operate.
It's going to do this, and that's like, yeah. So I think I'm going to have to go with my original design. We had to cut. So it made this nice channel in there, but you can see where it got caught up. Okay, so we had a bond line failure. We had a bond failure right here, which is why it wouldn't come out. We struggled to get this out. So all I got to do is prep the crap out of this, wax it, and we got to make another one because we had to cut the top of this thing out just to get it out. But I wanted to see the fit, and the fit is good. The fit is nice. I think I can get all of this to close up, and reasonably symmetrical. It's quite symmetrical for being carved by hand.
Looks good, really.
Yeah, I'm pretty happy with that, and it's light. These are it's a couple pounds. That is as light as I can reasonably make a man-rated part. All right, so these are good. These are all coming in under 2 pounds or under 3 pounds. Happy with that. Fits good. So the machine has been running in the background almost constantly, and I have figured out how to make it cut aluminum. I finally got the speeds and feeds for the aluminum to work.
So that cut like these, huh?
Yeah. So these are bell cranks for the.
Oh, they look nice.
Yeah, they look they're good. They're good. You know, I clean them up and then I grain them. Graining, I take 320 and I put a grain on it. A little bit of handwork, but they're very, very close to net finishes.
Well, that's so much better than when we used to cut them out and drill them in.
Oh yeah, it's way cleaner. And then this is a 3570 ream, and I take these holes out to 2505, and that's about right. So I'm really happy with that. It's not fast, but if it works in the background, I don't care. This is not a machine that's designed for heavy production, but if you baby it off, you can get this to work. It chatters, it doesn't like it, but it will do it. So what I do is I bond it to a piece of MDF with 3M77.
MDF?
This is a MDF, medium density fiberboard. I use this all over the place. And so I use 3M77 and I bond the aluminum to the board.
So that's a fiberboard, huh? You made that board, huh?
Yeah, I go buy this at the hardware store and we cut it to size. And then I put this in the machine. That keeps the chatter to a minimum.
Are those imprints the parts?
Yeah. So that's the cut. So it cuts down through the aluminum and cuts just into this spoil board. Right? It keeps me from getting into my machine's board. Right? It's called a spoil board. Anyway, doing it with 3M77 works really well. You just bond it down, and then there's a bunch of interior parts that get cut out. And if you look in here, Dad, you can see this was one that, you can see that this is farther than this one. What happened is, this machine skipped a couple steps. Right? These are stepper drivers in here, and if you overload the machine, it'll stop, and it'll lose steps. It lost quite a few steps, and it put it in the wrong location. You have to really baby this machine up. This is an 1/8 inch short carbide end mill, and I'm running it at 100 millimeters a minute, which is pretty slow. Actually, I think the magic number is 75 millimeters a minute, and I'm doing 1/4 millimeter depth of cut. So I'm just babying it off, and my chips are almost atoms, but it's very light chips, but it does work. It will chatter. It doesn't like it, but it's producing results. Anyway, so that's been running in the background because what I want to do is get these big assemblies. These are big, complicated assemblies. I want them done so we can start populating them with stuff. All right. So this is the seat. This is the seat. Go ahead. Katie's back there drilling holes. So Katie, sidebar. Katie is making us a test rig. We have we went out and we rednecked it together yesterday, but we got some good numbers on the horizontal stabilizer. We know that we're going to be able to make a load on this, but we're going to refine the process a little bit and get better numbers and get some good deflection numbers. But bottom line is, it's going to work. We have the right strength. It's going to work. We'll get into that in a minute. But what I'm doing is laying out the paper templates for the seat back. And this is a piece of MDF, and we're going to apply this into the mold right here. It's going to create a really nice return flange, right? And we'll bolt this in place. We'll laminate on top of it, and then we'll unbolt it, and we'll let it come out with the part, and then we'll punch it out, and it'll make a really nice, like, flange return. Okay.
Is that what's going to hold the seat in place?
What holds the seat in place is that there is a bulkhead that goes right here,
okay,
and it will screw in, probably with number 8 screws.
So is that going to hold mechanical devices for the controls, or?
All this does is create a hole here that has a flange on it, so that we don't get a really raw hole.
Okay.
Okay. All this is going to do is create a feature here that creates a little flanged hole.
Okay.
Because back behind here is all of the control systems. And that's what I'm working on over there. I want to have all of that built up. Once this part shows up, these are all of the other templates. These are the core templates for this. So once that part shows up, these go into place. So it's like, fuck. How did I do this? Man, how did I do this? Oh, there it is. Okay. So right here, there'll be a hard point, and then the controls, those brackets will hang off of here, and then the stick assembly will be up here, and it'll slide back and forth and push these. Okay, so all of this, and then this is a part of the core here. We'll laminate over the top of this. This will become the hard point for the rear rudder pedals and for the seats. Okay, and then this will be 3/8 core. We're going to start using the 3/8 core as opposed to the 1/4 core. And then this will be right here and create a nice how to do this. There it is. And it will create a nice return flange because you've got to be able to get your hand in here and hook all this stuff up with it in the airplane. All right, and so there'll be a hole here with a flange. We'll cover that with the upholstery. We'll put a piece of, Katie's going to do the upholstery. He's been working on a way to do upholstery by vacuum bagging it down over some molds.
With glue.
Yeah, by forming the leather.
Right.
By forming it down over some foam.
Over the foam or whatever you got.
Without folding it. It's kind of a pet peeve of his.
Yeah.
He flies a lot, and all of those. All those stitches. That's where the wear happens.
It's fair to say he's been in a lot of seats at over 10,000 hours, right?
Yeah.
Okay.
So this is he's going to work out how to do this and mold it into place, and we'll back it
Makes
out. Makes
perfectly good sense.
Yeah. And then we'll back that out with a Lexan. So back in the day, I apprenticed with an upholsterer. We would do our day job over on the one side of the airport, and then at night we'd go do upholstery on the other side. His name was Rick. He would use Lexan as a backer, right? A really thin Lexan. All you got to do is score it, and then you can tear it. Right, so use that as the back, and then you do the foam and the rest of it. Anyway, that will cover the hole, and when you need access, you just pull out the upholstery, pop your arm.
Oh, that's
So
great.
that's what's going on. I want to get this done. This has been trimmed up, and it is under 5 pounds. And we're playing around with a hinge on the back because there's a lot of area here that we can use. Okay, you can throw headsets in here and everything else. The only thing that's going to be back here is like a 4 by 4 inch by 4 inch block that is the HVAC system. So there's a lot of space here that we can use for personal items. And then this overhangs on the top, and then we'll probably just put twist blocks here. Twist this open, drop your stuff in.
Are you going to put those locks they put in the hood of a hot rod car or a Mustang or something like that?
It's called a Zeus.
Is that what it's?
Something you can do by hand. They make them that have.
Oh yeah, a little.
They have a.
Yeah, snap down.
Yeah, and then these are going to get put in location. Right here, Dad. I think this is the answer for getting blind fasteners in. These are a FAA approved item. They're called a rib nut, and these particular ones are flush. And I bought a bunch of these in the tool. I just wanted to see how they work, but it looks like theirs are going to work beautifully.
Cool.
Okay, so this is how we're
Put them
going
in,
to
snap them in, almost like a pop rivet or
It
something.
literally is a pop rivet. You can see it get distended on the back.
Oh yeah, yeah.
Okay, and then it puts a thread in here. These are FAA certified parts, and I the more I play with them, the more I like them. We can get these in 8s and a number 8 that's flush. I kind of wanted to do number 10s, but the reality is that's probably a little overkill for most of this stuff. The 8s are going to be great, so we're going to go that way. This was the last bit of the tooling for this. Just stay there, Dad. Let me get the. So what I had to do here, first I had to take the foam off of this thing because it was a disaster. It had changed shape. But once I pulled the foam off, the shape came all the way back. This is a hard point that gets bonded in to this, that holds the horizontal stabilizer and serves as the hard point, the hard mounting point for this in the fuselage and for the vertical stabilizer. And I had to locate this in a way that was sacrosanct. So I had to build a little bit of tooling. And this will locate it. We will prep this for bonding. Prep for bonding on aluminum for something like this is we wet sand with the resin. Okay. What happens to aluminum when you bond it is that if you sand it, it will instantaneously put aluminum oxide on the outside. The way you stop that is that you wet sand it with the resin. Okay, and it seals it from creating the oxide. And then you just wipe it off. Don't wipe it completely off, but you wipe the excess off, and you're ready to bond. Okay, and we're going to laminate on top of this because there's a lot of torsional stress that comes through here, as we have demonstrated by bending a steel tube. There is a lot of torsion coming through here. So there's going to be a bunch of cross plies in here to transmit this torsion into here. All right, transmits, and then this becomes a double torsion box and reacts that twisting motion into this hoop tension. Sweet. We did that, testing the first one. Wow. We twisted it. Wow. We had to go to a 1/4 inch wall to get this to work. Now, Katie rebuilt it. We're going to do a 1/4 inch wall, but that's how much force is on that thing. Took it like a champ, but it bent the steel. Yeah. So that's what Katie's working on right now. He is putting together a rig. So you go ahead and stay there, Dad. So that we can use we got a load cell. This is a 2,000 pound load cell. And it measures tension and compression. And he's setting that up to use it in compression so that we can get good numbers and get some. I don't know that we're going to get good deflection, simply because the rig is deflecting too. So we're going to have to figure out a way to measure the deflection in the rig, and measure the deflection in the part itself. I don't think the part's deflecting very much from what we saw yesterday. It's probably, what would you guess, Katie?
Quarter to a half an inch at the most.
Yeah, and I'd say about 3/4 of that is in the rig itself. So we're really not deflecting very much. And we were up over 500 pounds yesterday. So we're going to do that a little bit more formally today. And we're going to use this load cell for the measurement of all of that. So my next move, put the bunny suit on and keep prepping all of this. I have to paint all of this. We're going to paint all of this white before we actually bond it together, because it's going to be next to impossible to prep all of this. So I'm going to get everything trimmed in, pull it apart, throw these parts in the grit blaster. Dad finished all this up. It's ready to be used. So we're going to throw all this in, prep all this, and paint it. And I bought some paint. So we're just going pure white. The whitest of all pure whites. We're going to paint all this white. Probably this. I think we're going to keep this. We're going to keep this as it is. A little bit of this goes a long way. The rock carbon thing's been overdone, but a little bit of it goes. It's a nice accent. We're going to paint all this and body work it until spring. So that's what's going on this week. All right, we are about to bond up the fan casing after 5 years. Yep, I said it. I made these parts 5 years ago, and now we're finally going to bond them up, because it is now time to bond them up. They have been prepped, 60 grit. We will clean them with isopropanol, and then we're going to put them into the rig here and bond everything up. That's awesome. Okay, we are prepped. Surfaces are 60 grit. They have been primed, cleaned and primed, and now we're about to do a massive, large area bond on all of these. Here we go. Every clamp into place. Nice squeeze out everywhere. We put the tool that made the center bulkhead in the rear to hold it concentric, at least hold it round. Yeah, happy with that. I can't really ask it to be any more than that. We cleaned up most of it, otherwise it would be concrete in the morning. And tomorrow, pop it out, clean it, and it's going to get some body work. And then all of these go on. These have mostly been prepped, but I think we're going to at least primer these before they get bonded on. Trying to do things when it's easy, because once this goes together, you're going to have to climb up in it. It's actually bigger than it looks. This is 48 inches and nose to tail, so it's actually bigger than you think. Anyway, that's success. Thanks, Katie.
Yep.
All right. Okay. The bond up of the front casing went pretty well, and now I have the rear casing clecoed into place. And the center cone is there. And all of those features. I'm evaluating fit. That fit seems to be pretty damn good. Not perfect, but pretty damn good. Close enough that a lick of paint and a lick of primer will make it all go away. The next is the end caps. They are from this mold right here. Those are the next things, and they get bonded onto these. I weighed it. She's just at 25 pounds right now. The end caps are going to be 3 pounds a piece, so there's 12. The fan casings, which go onto the outside, are 3 pounds a piece. There's another 12. Flying weight, read it and weep, is going to be about 50 pounds. Amazing how it adds up. Each one of those components is 3 pounds a piece, but there's a lot of components in this thing. So that's the read it and weep weight, about 50 pounds. It's about what I predicted. I can't make it any lighter with this design. There's a lot of stuff here. This is 4 feet long, and it holds 4 structural components as well as the fan. Anyway, I'm pretty pleased with it. I'm glad to see it all together. And the next move is to tweak all of this, and we're going to roll primer on the inside because it's easier to roll primer when it's apart than it is together, and then there'll be the trickery of trying to paint all of this in situ. It's going white except for the cone. We'll leave that a little carbon bling, but everything else is going white. Anyway, that looks pretty good. Again, 80% pleased. Maybe 85.